Hi, I'm Glenn Whitney, and I'm with the National Museum of Mathematics, and I'm here in the Dallas Arts District because we're partnering with talkSTEM. And I'd love to take you along with me this morning, a little taste of what we do in our math walking tours to show the math that's in the world around us. The key here is that math really imbues everything in the world around us. There's lots of things that I could talk about, but I'd like to start with something that we perhaps walk by every day, don't even give it a second thought, and show you that there's mathematics even inside those things. I'm gonna start right here with this traffic bollard. You'll see that all of the bollards are the same shape. Every single one is a cylinder. Why would that be? Is it because cylinders are just more attractive? Cylinders have no corner that you can bump into? Well, those might be the reasons, but there's actually an underlying mathematical reason why you see that shape over and over again. It's because the mathematics of the structure of the shape tell us that we can get the maximum stiffness with the minimum amount of material if we build a bollard in this shape. These brushed steel bollards that we have here embody another mathematical mystery. If you look at the reflections off of the top of this surface, as we know, light travels in straight paths. It's hitting this flat surface, and yet you will see curved reflections of the sunlight in the top of this bollard. Where could that curve possibly come from? What is that curve? How can we understand its shape? Mathematics can illuminate these mysteries.
We are today at Deer Park on the esplanade, the most important parts of this whole compound. Very Corey, and I know that you measured the length of this side of the triangle right here. What did you get for your answer?
77.
In this triangle, right here. Okay.
Here we are in front of the most beautiful and stunning, I would say, tower building in Fair Park. I'm with Jason. Thanks for coming out today, Jason. Jason Treadway is director of the STEM Institute at the Dallas County Community College District. So Jason, when I look at this and I see there's
A number of small little problems, and we can calculate how much gold we have. But the first thing is, if you notice the build area that we found in step 1 and divide that by 79 square feet, that gives us 23 and a half.
This is Lynn McBee, and I'm Trammell Crow. We're going to go through a mathematical, real-life application today at the Hall of State.
Well, let's see. We can notice that the facade of the building is a giant semicircle, and the horizontal rows of tiles are along the semicircle arc of its perimeter.
The perimeter of a circle is the circumference. So the length of the circumference is to do with the radius.
and what I noticed was the balcony up there,
Right.
and where the blue tile wall is behind the doors. So
Right.
we could figure out a way to measure from where you guys were standing earlier, all the way to the blue tile, which I am guessing is in line with the inner doors. Because architects like to keep things in line with each other. Why complicate life when you don't have to, right? If we could just add on the measurement from that last 6 flagstone
Right.
to the inner door, I
Then
think
we-
we'll be
yeah,
on
figure
the
it
right
out.
track.
All
So
right.
let's do that.
Okay.
Today we're at the Texas Star at Fair Park, and this is one of the largest Ferris wheels in the United States, which is super, super cool and exciting. We're gonna do some fun math, take it out of the textbook a little bit, and one of the questions that I always wonder is how fast are we going when we're on that thing? Right? Like, so if we think about it, when we're on a highway, about how fast do we travel?
Like 60 miles per hour.
Miles per hour. Now that unit is super important. What do you think we can do with miles per hour in order to figure out the speed that we're traveling at?
Well, I think at it as distance over time. So when you look at speed, it's another word for rate. And our equation for that's really easy. It's rate equals distance over time. Now let's move on to time, which is really easy. Go back to the information we got at the beginning. We know that you can do 1 revolution in 40 seconds. So let's convert 40 seconds into hours. And we're going to go ahead and get 0.011 hours. So then let's plug it all back into our first equation. Rate equals 0.1207 miles over 0.011 hours. And we get our rate, which is 10.9 miles per hour. So that's how fast you're going.
Oh,
Yeah.
interesting information.